Hey everyone, I'm Jonathan Ivey, and thanks for tuning in to this Python programming tutorial. Today we're going to learn about how to get the underlying data from a Google map, and we're going to use that knowledge to build a web scraper for Zillow data. We'll be using the libraries requests, BeautifulSoup, pandas, NumPy, regex, and OS for this project. And to make it a bit easier, I've added a link to the requirements.txt file in the description below. Great, and with that, let's get started. All right, so we're going to start by taking a look at homes for sale in Los Angeles, because that's the city that I live in. And whenever we're working on a web-based project, the first thing we want to do is familiarize ourselves with the website. So we want to understand the URL, we want to understand what's going on the page, we want to understand if there's pagination. We just want to understand everything about the website. So let's take a look at the URL. And the first thing we notice is that it's an HTTPS, and it's a fairly simple format for the URL. So we really like that. Okay, so now let's move on. Let's see, we have a list of homes on the right-hand side. So we're going to scroll down. Let's see if it has any pagination going on there and take a look at how that impacts the URL. All right, so when we click on the page, number 2, it changes the URL to have this long, complex tail. But what matters to us is this 2_p right here. Let's see if it changes to 3. If we go to the third page, probably will. And yes, it does. So we understand our pagination. Let's see if it works on the simple URL. And it looks like it did. It did. So we don't need to have that long, complex tail in order for the pagination to work. The next thing we want to do here is we're going to look at our map. And immediately we notice that it's firing off some data. And we're not refreshing the page. Nothing's refreshing. So that leads us to understand that this is probably network data. And so we're going to inspect our network data by pressing F12. And we're going to go into the XHR and Fetch tab. That's where we want to be. XHR and Fetch basically contains all of the private API calls that are internal to the website. And they fetch the data without us requiring to refresh the page. So the first thing I notice is that we have a get method, a get search page state method, and no other get methods. That's very nice for us. That's a status 200. So let's click into there and examine what we have. Immediately we notice we have a search results, list results, and perfect. This is in fact the method that we need in order to retrieve the data from this website. So how do we get this method into our Python code? We're going to right-click the get search method, and we're going to copy it as bash. And what I really love to do is I have this website I go to, and it converts the code from a curl command, which that's actually the format of command that this is. This is a curl command, and it converts it into a Python or whatever other language you want to convert. It's a code converter. I'll link the website in the description below for you guys to use yourselves. Great. Looks like it worked perfectly. I'm going to copy that over. Paste that into my Jupyter notebook. And first thing I'll do actually is I'm going to include the required libraries, which I've included in the description below for you if you'd like to download the libraries. I'll just copy it over myself, along with some pandas options. Don't need this, and we do not need this session requirement. We also do not need cookies. All right. Run this. And let's take a look at our response. Hopefully we'll get a response 200. Perfect. Now if we look at response.text, what does it bring up? It tells us to request JSON. When we request JSON, what do we get? Okay, we get an error. That tells me that the structure of their JSON is flawed. They have some sort of error in their code. Or at least it appears that way to me. So it's not really a big problem for us. There's an easy way to work around it. So we'll do that in the next section. So in order to get around the JSON issue, we're going to manually build our own response list. So we'll write loops to create lists for each page request. I'm entering the city as Los Angeles because that's my own city. The starting page is 1, and the end page, I'm going to put I'll put 10 for my own demonstration. You could put however many pages you want your loop to go through. Creating an empty null for URL, and I'm creating a URL list, empty list for URL list that I'll use in my loop. So I'll create a while loop here, and while the starter page, is less than or equal to the end page, URL will equal, and we'll go back to Zillow. We'll go to the original Los Angeles. And we'll delete, let's actually see if we can remove the RB as well. _P. We can, we don't even need the RB. So we'll remove that. Actually, we don't. So what we can do is we will remove the city, and we'll add the city. And we'll use an F function. insert page underscore P. And that should work. And what that does, well, let me finish the loop and I'll explain it. Append URL. Okay, so what this while loop will do is every time it loops through, it will add the page for pagination to the end of the URL, which is the simple URL plus the city at the end. And then it will increase the page all the way up until our desired end page. And that will create a list, it will append it to the list that we created earlier. That will create a list of the URLs with all the way paginated through that we can use for our requests. We'll create a similar list for requests. And I'll create a for loop to loop through the list. And I'll include headers from our inclusion. And by the way, we no longer need this because the JSON didn't work. So we don't need this any longer. Perfect. Okay. And now we'll build our beautiful soup. And we'll loop through the request list in order to build our beautiful soup objects. And we'll be using the HTML parser. And that will actually complete our loop. If we have any errors, there we go. All right, let's take a look at our soup list. What does that even look like? What it does is it creates an object of the HTML for our request. I'll cover how we extract our data from the soup list in the next section. So to extract the data from our soup list, we're going to want to build a data frame list, contain a list of data frames that we'll build from the list of HTML objects that we made with our beautiful soup. So for each object in the list, I'm creating a new data frame that I will fill with information from the beautiful soup object. Now I've actually already extracted the different classes, or I've identified, I should say, the different classes within the HTML that represent the attributes of the homes. So I'll paste that in now. And you can pause the video if you'd really like to take a look at the different classes associated with the attributes of homes in the beautiful soup object. Next, we want to create some new columns in the data frame. Associate with our attributes, prices, address, and beds. Here, I've previously written a for loop to loop through the URLs and identify the address in the URL and strip the address from the URL and append it as an href. Actually, what I can do here is I can copy and paste right here. And I want the links to be as tag string. And I also want to remove the HTML tags from the links. And finally, we append the DF to our DF list. And we loop back through the for loop again for each soup object in the soup list, building a new DF, adding it to the DF list until we have completed a list of DFs for each page, or completed a DF for each page. All right, great. No errors. Let's take a look at DF list 1. Error, yeah, let's take a look at DF list 1. Could be 0, but we'll go with 1. Why not? Perfect. exactly what we were looking for. Let's try 0 now. Great. Different set of numbers. Exactly what we want. We can move on from here. All right, so the next thing we're going to want to do is we're going to want to concatenate all of the values in the DF list into one data frame. And resetting the index, because all of the different indexes will pile on top of each other. We don't want that. So we want to reset the index. And then we'll drop the new index column that's built when you reset the index so that we maintain a clean and tidy data set. We'll check DF head. No, we'll check the whole thing. We want to see, did it work? Perfect. So the reset index worked. And we know that this is the second. Looks good. Looking good. Perfect. So now we want to convert our address column and our beds column into strings. So we'll do df We'll keep it separate in case we want to change them into different types of different data types. So I want to keep these columns separate. Great. Okay. So as we can see, we have a lot of weird tags in our beds column that we do not like. So what we're going to do is we're going to, and there's some tags in our addresses column actually that we don't like. So we are going to remove all the HTML tags from beds and address column and replace it with empty values so that we can clean up our data. I've already done this, so I'll just copy and paste that in so we don't have to sit here and watch me code a long block. And of course you can pause and take a look at it yourself if you'd like to copy this, but I will have a link to the source code of this project in the description below if you'd like to try this project yourself at home. Fantastic. All right, let's take a look at the beds column now and see what happens. Yeah, great. See, it looks much cleaner than it did before. And what we have are the numerical values followed by the type of property. So how do we deal with this? We want to split this up because it's not beds. This is the numerical values of the house, beds, baths, square feet, and then the house. So first thing we want to do is we want to split the column between the type of property and the numerical values. So df beds, and we'll add a new column type. And we'll use a lambda function here, which is a condensed for loop, actually. So x such that x in a series split that x by the dash. And that should work. Check our df now. We can just check the head actually. And look at that. We split our beds column by the minus sign, the dash. And now we can take our final step and split the beds into its several different pieces of beds, baths, and square feet. And there we have it. Beds, baths, square feet, type, links, address, and prices. Fantastic. And thanks you for watching this Python tutorial with me. It was a great time doing it, and I hope you stick with me for another one in the future. Signing off. Thank you for watching this Python tutorial. Please like and subscribe, and always remember, make sure your decisions are data-driven.